In this video, we are going to look at transformations of graphs. So just like transformers take something that is in one shape and they change it into a different shape, our transformations are going to change the form of the graph. Okay, let's look at these two transformations first. In both of these cases, the original function is the dashed one, and the transformation, the one that has been changed, is the solid one. Okay, so look at number one. Look at that dashed one. How has it changed to become the solid one? Well, I can see that the dashed one has been moved down to become the solid one. It hasn't changed its shape, it has just changed its location. So let's see how much. I've got 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5, 6, 7. Let's try this one. 1, 2, 3, 4, 5, 6, 7. It's important that every point has been moved down the same amount. So the change here is a change that is down 7. The way we would write this is that we have f of x minus 7. The whole graph has been moved down 7 units. Okay, look over here at number 2. Again, the original function is the one that's dashed, and this time I can see that it has been moved up to be the solid function. So let's see how much. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, they've been all moved 1, 2, 3, 4, 5 units. So in this case, the change is up 5. And the way that I will write that in function notation, my whole graph f of x has gone up 5. Notice that the number that is added or subtracted is on the outside of the function. The x is on the inside where the parentheses are, and the minus 7 and the plus 5 are on the outside. Okay, let's try number 3 and 4 because those are different. In both of these cases, just like before, the original one is the dashed one and the transformed one is the solid one. So look at what has happened here. Our dashed one has moved to the left. So that's 1, 2, 3, 4. 1, 2, 3, 4. They all have been moved left 4. Okay, so if up and down were on the outside of the function, right and left are going to be on the inside of the function. So if I want to move left 4, I'm going to put that 4 on the inside. Okay, that plus is probably not what you were expecting. You were probably expecting a minus there, but this one is defined a little bit differently, and we'll look at that in just a minute. Okay, let's look at number 4. How has the dashed one moved to become the solid one? 1, 2, 3, 4 places to the right. 1, 2, 3, 4 places to the right. All right, every point has been moved to the right 4 places. So if plus 4 moved it to the left, what do you think is going to move it to the right? If you guessed minus 4, you were correct. That's f of x minus 4 with the x minus 4 in parentheses because we're moving to the right. All right, another transformation we need to look at is this one. A little bit different. It hasn't moved left, right, up, or down. What has happened is that the whole thing has flipped over. So it used to start over here and move up. Now it's starting here and moving down. The horizontal line was below the x-axis. Now the horizontal line is above the x-axis. This whole thing has been flipped. And the appropriate math word there is that this is a reflection. We want to practice with our good vocabulary. This is a reflection. So think about what happened here. These positive y values became negative y values. And these negative y values became positive y values. So everything has flip-flopped. All the positives became negatives and all the negatives became positives. So to change the sign, we multiply by -1. So that negative or -1 out in front of the f of x that's multiplying there is going to be our flip or our reflection. Okay, so recap. Look at numbers 1 and 2. Look at what you wrote there. Remember that the plus k, when it's on the outside, that is going to move our graph either up or down. And think about what kind of numbers did that. To move the graph up, we had positive numbers. Whereas to move the graph down, we had negative numbers. Okay, when it's on the inside, it's going to move the graph either to the right or to the left. Okay, look at the way this one is defined. You see that it's defined as x minus h, whereas this one was plus k. So that's why this one is going to move the opposite direction. If I am subtracting a positive number, right, that's the same thing as adding a negative. So I'm going to move to the right. And if I am subtracting a negative, that's the same thing as adding a positive. So I'm going to move to the left. So it's going to go the opposite of what you see in the parentheses. Positive numbers are going to move the graph left, whereas negative numbers are going to move the graph right. And then the last one, this little box should not be there. It just should say -1 times f of x. That reflects the graph over the x-axis, right? Everything that was positive becomes negative, and everything that was negative becomes positive. Okay, so let's look at this one. We are going to sketch this one. I've got my graph g of x, that's the solid one that's here, and I want to graph g of x plus 5. Okay, so that plus 5 is outside of the function. All right, so look back at what you wrote in the recap box. Which way should this one move the graph? It should move the whole graph up 5. So the way we're going to do that is we're going to take each of these points and we're going to count up 5. 1, 2, 3, 4, 5. And we'll put a dot right there. Now to this one. 1, 2, 3, 4, 5. We'll put a dot right there. And now over here, 1, 2, 3, 4, 5, putting a dot right here. And now this one, 1, 2, 3, 4, 5, putting a dot right there. So when you guys get ready to do this in class, I'll have straight edges that you can use, and then we'll just use those straight edges to connect the dots. And now I have graphed g of x plus 5. The black graph, the original graph, is g of x, and the blue graph, the transformed graph, is g of x plus 5. Okay, let's look at this one. So this time the plus 4 is inside the graph. Okay, so look back at what you wrote in the recap box. When it's inside the graph, or inside the function, which way should it move? It should move left or right, and it's going to do the opposite of what you think. I see x plus 4 there, which means it's going to move to the left. Remember how this one was defined with the negative? Right, this is really g of x minus -4. Minus negative, same thing as positive, and so therefore it is moving 4 units to the left. So when I see plus in here, I'm going to move to the left. And I'm going to do exactly the same thing as I did before. I'm going to take every point and I'm just going to count. 1, 2, 3, 4. And now this one, 1, 2, 3, 4. And this one, 1, 2, 3, 4. And up here, 1, 2, 3, 4. All right, and then I'm going to take my straight edge, just like I did before, and I'm going to connect the dots. So you guys will do exactly this same thing when you work on your worksheets. Okay, so you can see that the black graph, again, is the original g of x, and the blue graph is the transformed g of x plus 4. Okay, so now let's look at this and let's describe the change that we see. So I have, for number 8, f of x equals x to the 5th plus 9. Okay, well, my parent function, the main thing that I'm looking at, is going to be x to the 5th. And what is that plus 9 going to do to my graph? Okay, look back at your recap box. Which way should that plus 9 move the graph? It should move the graph up 9 units. Okay, and if I take number 9, f of x equals absolute value of x minus 15, well, my parent function is absolute value of x. And what do you guys think that minus 15 should do to the graph? If you picked down 15, you would be right because it's on the outside. Okay, so I've put that first one in the calculator. You can see I've got the parent function of x to the 5th, and then you can see I have the transformed function of x to the 5th plus 9. Let's look at the graph. So the original function coming up now is going to be the blue one, and then my transformed function is going to be the red one. And there it is. So you can see that the whole graph moved up 9. Okay, so now I've put the second one in there. You can see I've got the parent function of absolute value of x first, and then I've got the transformed function of absolute value of x minus 15. So just like before, the parent function is going to be blue, and the transformed function is going to be red. So let's look at the graph of that. So here's the absolute value of x. It makes a v. And the absolute value of x minus 15 is so low it moved off the screen. Well, if I want to see that point down there, I want to see the vertex, what I'm going to do is I'm going to change my window. I need to make that y value a lot smaller. So I'm going to go to y min, and I'm going to make it, instead of 10, negative 10, I'm going to make it negative 20. All right, so there's my original again. And then here's my transformed graph, and I've moved the window so that I can see it. I'm down there at negative 15, and you can see that it has moved down. Okay, let's try these. So looking at number 10, this time do you guys see that my 3 is on the inside of the function? So if I want to look at this one, the parent function is still x to the 4th. It's just plain x on the parent function. But the transformation, what does that negative 3 do to the graph? Well, it should move the whole graph to the right 3. Okay, let's look on our calculator and see if that was right. Okay, I've got my x to the 4th in there as the parent function, and then I've got x minus 3 in parentheses to the 4th as the transformed function. And if I look at the graph, there's x to the 4th, and there's x to the 4th minus 3. It's scooted over to the right. All right, if I wanted to put this window back into the quote-unquote normal position, do you guys remember what we looked at in the other video? You remember how to do that? You go to Zoom, and then go down to number 6. The standard viewing window is negative 10 to 10. So I'll put that back in there so we can see it a little bit better, a little bit closer in. And there you can see is the original, and there you can see is the transformed function, 3 units to the right. Okay, so let's look at x plus 9 in parentheses squared. The parent function this time, what do you guys think the parent function is going to be? Well, it's going to be x squared. Remember, the parent function is just plain old x. And then what does that plus 9 do to the graph? It's going to move it to the left 9 units. Okay, let's look at that on the calculator. All right, so I've got x squared as my parent function and x plus 9 in parentheses squared. Let's see if we got it right. Let's see what happens when we graph this one. So x squared is a parabola. You guys did those in Algebra 1. And there's x plus 9 in parentheses squared. Again, I can't see it very well. It would be nice if I could see a little bit more of it. How about if we move our window to the left? Well, if I want to go to the left, the thing that I'm changing is my minimum x value. So I'll go to my window screen. I'm already on x min. Let's make that negative 15 and graph it again. So here comes my parabola in standard position. That's where the parent function is. And then you can see I've scooted over 9 units to the left. A little bit easier to see when I have a different viewing window. Okay, let's go to the next one. All right, the parent function on this one, just going to be plain old x. So it's going to be x to the 2nd without the negative. All right, do you remember what that negative did? What did we put on our paper that the negative does? It is a reflection. Okay, so let's look at that one in the calculator. All right, I've got x squared and negative x squared. And if I want to go back to the standard position, I'll just go ahead and do zoom 6. It'll automatically put me in the standard position. There's the parent parabola, and there's the reflected parabola. Okay, we're going to stop the notes at this point, and for our warm-up tomorrow, we are going to complete the rest of these notes together.